Hello and welcome back to Secure Sushi. This is part 2 in our Blackhat with Go series, where we're following the Blackhat Python concepts, but we're recreating them in Go. In part 1, we created a TCP client, and in this video, we're going to create a UDP client. Before we get started though, I just wanted to explain some of the operators we used in building the TCP client that I probably didn't fully understand myself and didn't fully explain. So the first one is the blank identifier, which is the underscore character. So this can be used for a number of things in Go, but in the example of our TCP client, we can see here on line 26, we've used the blank identifier, and in this scenario, it's actually discarding the first return value. So if we're looking at this piece of code, the first return value is going to be the number of bytes coming from this request, from the request variable that we're getting the response back from google.com. But we're not interested in the number of bytes. So what we're going to do is actually discard the first return value, which is that number of bytes, and we're only going to be interested in the second return value, which is anything that's in that error variable if there's an error. So effectively, we're discarding the first return value and only keeping the second return value. So where you've got pieces of code that do that, that's one of the uses for the blank identifier. The other operator I wanted to talk about is the short operator when you're declaring a variable. So in Go, there's a number of ways of declaring a variable. So we can start with the var keyword, and then we can give it a name. So for example, that's going to be the name of our variable. And in this example, we're going to have an integer. And then we can say it equals 1, for example. So in this example, we've said, this is a variable with the name I, its type is an integer, and we've actually declared the number, the value, of what that is. The other way we can declare a variable is by inference. So we can do variable again, this time we'll give it the name A, and we can just say equals 1. And based on the value there, Go will infer that that's an integer. That variable will be an integer. Or we could write a string, and Go would infer that that's a string. Now the other way we can do it is we can actually initiate and declare a variable all in one with the shortened operator. So for example, we can just give it a name. So we're going to call this one count, and we use the shortened operator, which is the colon and equals, and we can say equals 1. So you can see, instead of having to say have the keyword var, and then a name, and then a type, and then the value, or the keyword var and a name and a value, we can just say this is the name, this is the value, and Go will just do the type inference and also understand that that's a variable. So it's just a shortened way of declaring a variable within Go. So I hope that's useful. And going forward, we're probably going to see this in our UDP client as well. Okay, so with that explained, let's get going on actually creating our UDP client. So to start with, we're going to need the format package, we're going to need net, and I think we're going to need OS again. Okay, so it's going to be a little bit like the TCP client. It should be fairly similar. We're still using the net package, but we're going to be using UDP as the protocol. So the difference is that TCP is connection orientated. It's got a lot of error checking and things like that. UDP is kind of a lot more lightweight. So when you send something with UDP, it doesn't really check if there's something listening at the other end. It's just going to send that data, and it doesn't have much in the way of error checking or that sort of thing. But it's got its uses for things like video streaming or music streaming, things like that, where it's just sending the data and having the overhead of actually checking if the data got there would just slow it down. So first things first, we're going to define a UDP server to connect to, because this is the client. So for now, we don't have a UDP server right now, so we're just going to make something up. But let's get started. So, oops. All right, so we're going to start with a variable of server address, and we're going to have a error variable as well. And we're going to use the net package here. So we're going to use net.resolve address, I think, resolve UDP address. Yep. Okay, and we're just going to have UDP there, obviously, and we're going to have the server name. So we're going to put in the server name and a port. Could be whatever, 9988, for example. Okay, so now we actually have kind of set up our server address. We're saying it's a UDP connection, and it's going to be on the localhost address on port 9988. And we're always going to do our error checking. So let's put in some error checking here. So if it's not nil, then we're going to print out something. So we're going to use our format.println. And in this case, because it's an address, we're going to have something to say, you know, error resolving address. I don't know where that server is. So we're going to put that, and then we're just going to drop that, because if we can't get to the server, we can't do much else. So that's basically defining the server address and port. So in the next part, what we want to do is actually create the connection to the server. So again, this looks fairly familiar to how we did it in the TCP client. So we start with the connection variable. Again, we're going to have our error. But this time we're going to use, so we're going to use netdial again, but we're going to use netdial UDP instead of TCP. And we're going to say it's UDP. Okay. So ladder is going to be nil. If ladder is nil, a local address is automatically chosen. If the IP field, so local address. So we're just going to leave it as nil for now. And then we're going to give it the server address that we actually want to connect to. And again, if error is not nil, we're going to do format.println, and this time we're going to error connecting to server, because it's building the connection to the server. So if there's an error, then it's going to be with the connection. And again, if we can't connect to the server, we're going to exit, and we're going to close the connection as well. All right. Now, if all's gone well, and we've defined the server address, we've created the connection object to dial or connect to the server. If all's gone well, then we actually want to send a message to the server. So the next thing we want to do is define what that message might look like. So let's start with a variable called message. And what are we going to say? Hello, Blackhat with Go, UDP server. And again, and funnily enough, line 26 again, we're going to use the blank identifier. So as I explained at the beginning of the video, in this case, we want to drop the first return value. So as we write this out, so So we're going to use connection.write. So we actually want to write the message above. And we're going to do that in bytes. We're going to convert that to bytes. And there's our message variable that we just declared above. But we don't really care about the bytes. Again, that's why we're getting rid of the first return value, which would be the number of bytes this message equals. We don't care about that, but we do care about the, if there's any errors. So now we need to define our error handling again. So it's pretty much the same as before. This time we're going to use format print line, and we're going to say, error sending message, because that's what we're trying to do. All right. And again, if there's an issue, we're just going to exit. All right. And then if we got a response from the server, so we've sent a message to the server, and maybe that server is going to send a response back. So we need to be able to read that response back. So first things we want to do is actually create a buffer that can hold that data that's coming back. So then we can do something with it. So we'll create a variable called buffer. And we're going to make that a byte string, and we'll make it a 1024 byte buffer. Okay, now in this one, we're going to define a couple of variables here, and we're going to read from the UDP response, or from the UDP buffer, I should say. And again, we use our error handling to detect if there's an issue. And we're going to say, format our print line. What's the error going to be? Error, we're trying to read the response from the server. So error reading response from server, error. And if there is an error, again, we do the exit. And then if not, we want to actually, if it's all successful, we actually want to print out the response. So for this one, we'll just say server response is, and we're going to grab that buffer, and we're going to print that out to the screen. And that's pretty much it. That's our UDP client created. So it's fairly straightforward, fairly similar to the TCP client. So just to go through this again, at the top here, we are declaring the server address that we want to connect to. Now, that doesn't exist right now, so when we try and run it, we're most likely going to have an issue. But this is actually just defining the server address. We could do it, we could ask for an input of what server we want to connect to, and maybe that's something we can change going forward. The next part here is actually using the net dial command, or function, I should say, net dial function, to actually connect to the server address we specified above. Then we're going to send a message. So the message we've defined is hello Blackhat Go UDP server, and we're going to write that across that connection. So we're going to send that to the server. Now, if we've sent that to the server, maybe it's going to send a response back. So we've created a buffer here, 1024 byte buffer, and we're going to read back any response from the server, and then we're going to try and print that to the screen. And that's pretty much it. So we will go ahead and save this. Oops, wrong button there. Save that. And then we should be able to actually run this file. Give me 2 seconds. Sorry, just had to look up the command again. So it's go run, and we're just going to use main.go because that's what we've called it. Because I'm not in the bin directory, it's my fault. And let's see what happens here. So at the moment, that should be trying to connect, and it can't because there's no server there. So I'd expect that we should get an error coming back shortly. Haven't got anything yet though. So I've been doing a little bit of testing. It seems like the code just never exits. It's almost like a timeout, like it's just continually trying to connect. So this is the reason why, like TCP, for example, waits for a response, and then sends its next piece of data, waits for the response, etc., etc. It's got a bunch of error handling and stuff built in. Whereas because this server doesn't actually exist, UDP is just trying to connect and there's nothing there. So I think it's a timeout problem. Doing a bit of research, I think we can put in like a timeout function, or a timeout a piece of code that basically has a timeout so that it'll cancel and quit if there's no response in that time. So there's looks like we can use set read deadline and give it a time, and we put that in before the buffer here. So okay, where we're waiting for the response, we can put the timeout before the response. So if we don't get anything within a certain time period, it should time out and then quit. So we're going to set the read deadline so it's not just sitting there trying to wait for a response back from our non-existent server. So time.now and .add, and I'm going to use a 5-second timeout. I think that's correct. And what's the problem here? What's like undefined time? Set read deadline. Time.now. Do I need to import time? Yeah, I think I need to import time. Is that what it's complaining about? Yeah, there we go. All right, let's save that, and we'll see if our timeout now works. So it's actually still trying to run here. All right, so let's give it 5 seconds, and we'll see if something happens here. There we go. Right, error reading response from server. This is the local host and port, and it's trying to connect to itself effectively, but we've got a timeout, and we've got error reading response. So it basically, like I said with UDP, it just tried to, it could resolve that. It tried to connect to it and probably sent the message, and it's waiting for a response back and never got one. So it's just infinitely sitting there waiting. So by putting in that timeout, at least now it'll quit after 5 seconds if there's no server responding. So that's our UDP client created. I will upload the code to the GitHub, and I think in the next one, the next obvious thing is actually to create the servers. So we can create a TCP server, we'll create a UDP server, and then after that we'll get on with some more interesting stuff. But this is just the basics of creating some networking clients. And what I forgot to mention also in the first video is the whole premise behind the Blackhat Python kind of book is, if you're an offensive security person or you're a hacker, and you get onto a system, it's not, the tools may not necessarily be installed there. So you might not have like Netcat, or you might not have whatever the your favorite tool is installed on that machine, and you might not be able to install it, or you might not want to, say, download it and trigger any alarms or something like that. So if you can, on most systems, you're probably going to find Python's installed, which is, kind of the premise of the Blackhat Python book. If you can create those, like a TCP client where you can connect out, or a TCP server in Python, then you can, you probably get a payload onto that system. And we're doing the same with Go. It's probably less likely that Go is going to be installed on the system, but we're just doing it for a bit of fun to see if we can kind of follow these concepts and build the same things out with Go, so that we can learn the Go programming language. But again, thank you for watching. Hope you're enjoying this and looking forward to the next one.